Hariom children, this is exercise number 5.6, sum number 1. We are going to differentiate the given expressions. Roman number 1, find dy by dx for the following functions. We will keep this function as y. We will differentiate with respect to x. Okay. Now, so first question, xy is equal to tan of xy. First, we will apply product rule for the left hand side. So, product, what is product rule? Dy by dx is equal to uv dash plus vu dash. So, this is u, this is v. Now, when we differentiate, what we will get uv dash, u is x. We differentiate with respect to x, this will be differentiated as dy by dx plus v is y, u dash. If you differentiate with respect to x, x will be 1. The constant term will be 1. For the right hand side, apply chain rule. Tan xy. Tan, if you differentiate, we will get secant squared. Inner part we will not disturb first. Secant squared xy. Again, this part must be differentiated. Okay. So, secant squared xy. First we are differentiating tan alone. Then we are differentiating xy alone. If we differentiate tan, you will get secant squared, and xy we will keep it as such. Now differentiate xy alone with respect to x. Same this rule. uv dash, u and v. U will be x, v dash dy by dx plus v, keep it as such. V is y, u dash with respect to x. When you differentiate x, you will get 1. Okay children, the next step, x into dy by dx plus y into 1 is 1. Secant squared xy. This x, I am going to multiply this term secant squared xy with x dy by dx and with y. Y into 1 is y. Okay, now I will get x, bring this x forward. X secant squared xy dy by dx plus y secant squared xy. Secant squared xy. Xy, put it inside the bracket. Now collect all the like terms. X term to the to one of the sides and y terms to the other side. Okay. Now x dy by dx, you can keep it on the left hand side. Bring this term x term to the left hand side, so it becomes minus x secant squared xy into dy by dx on the other side, that is on the right hand side. Y secant squared xy you can keep as such. Bring this plus y to the other side, you will get minus y. I'll take for these two terms dy by dx as common. So the remaining will be x minus secant squared xy. Here you can take x also as common outside, but we will do it in the last step. Okay. Here you can keep it as such. Y secant squared xy minus y. So dy by dx equals y secant squared xy minus y, the whole divided by x minus secant squared xy. Now take y outside. The remaining will be secant squared xy minus 1, the whole divided by x I am taking common outside, 1 minus secant squared xy. If you see, you can notice that dy by dx. You can notice that the minus sign alone changes here. The sign alone changes here. So, I am taking minus common outside in the numerator. So, I will get minus 1 as plus 1 and rearranging the equation and writing directly minus secant squared xy. Plus secant squared xy will turn into minus secant squared xy divided by, in order to simplify only I am doing this. Okay. So, secant squared xy. So, the terms are same. I am cancelling it. So dy by dx is equal to minus y by x. So that's all about Roman number 1, sum number 1. Hari Om.